In this video I'm going to convert some data that have been saved from a Bruker NMR spectrometer in a JCAMP format that is now available as a conversion filter in CasaXPS. So this is the format of the data as exported. Lots of header information and data. We can use the file filter, so we can just look at in the convert to VAMAS file dialog window the .dx files that contain the data, and then select a DX file and press open. Once the file has been converted, a new VAMAS file is written back to the directory and the data appear in CasaXPS displayed as intensity with respect to chemical shifts in ppm. If we want to see the chemical shifts relative to some reference peak, for example this one, then this can be achieved by calibrating using the calibration property page on the spectrum processing dialog window. But first we need to identify the peak maximum, and we will do that using a region, and the position of the peak is determined using the CalcMax option, which fits the curve to data bins rather than accepting simply the maximum intensity in a data bin. This interpolation should improve precision of the peak maximum. And then using the spectrum processing dialog window calibration property page, if we select the region, bring in the measured value from the region and assign the true value as 0, so this is the reference peak will be set to 0 in terms of chemical shift. We'll adjust the region for the sake of completeness. This means that the region will move at the same time as the data in terms of energy. So we then apply, and we end up with a 0 for the reference peak, and these other peaks are then displayed in terms of chemical shift in ppm relative to the reference peak. The spectrum that was calibrated is the one that was displayed in the active tile. These files actually contain two traces. The first one that I've selected is the real part of the Fourier transform of the frequency domain that is collected by the NMR instrument. The second, which is part of the data file, was the imaginary part of the time domain that was converted by this fast Fourier transform operation. So we have an imaginary number for each data bin. And this gives me the opportunity to show you that when I overlay these, only one was calibrated, the other was not. And if we look at the spectrum processing dialog window, we have the calibration instruction that is displayed because the spectrum that was calibrated is the first that was selected in the right hand side when I overlaid these two spectra, and so this one is showing you the calibration that was performed. The other one is obviously not calibrated, but we can calibrate by selecting and then right clicking and choosing only the option that says processing in the browser operations. So we're going to propagate the calibration from the source, which is the first one selected, to the selected VAMAS blocks. Now both are selected, so they are both listed, and when I press OK, this calibration instruction will then be applied to both of these spectra, and so now both align. And it's not confined to transferring the calibration to spectra within the same file. You can calibrate to any file that you can select. So you load files and you select the VAMAS blocks, you bring up your reference peak, and then you can propagate in exactly the same way to spectra that are in different files to have exactly the same calibration.